Okay, dissolution of ionic compounds is basically you dissolving your ionic solids. Ionic solids like salts, Okay, so they are made up of positive and negative ions attracted to each other by electrostatic forces. So when you dissolve your salt, let's say in water, okay, dia adalah ionic solid, you will have an enthalpy change. So this delta H is called delta H solution, or another name is dissolution. Okay, delta H dissolution. This is when you dissolve your ionic solid in water, you should get aqueous ions. Okay, this process, delta H solution, is actually broken up into two stages. So the first stage of your solution process is delta H lattice, if you recall. So this one is when we have our crystal lattice, let's say an ACl solid. Okay, it will be absorbing energy to break the bonds, okay, to form gaseous ions. So gaseous ions you should get, okay, Na plus gas and Cl minus gas, okay, daripada awak punya ionic solid tu. And after that, this one here, the second stage is you change your gaseous ions, okay, you hydrate it with water so that it will form your aqueous ions, okay. So enthalpy of solution of ionic crystal in water is the sum of, okay, delta H solution of your ionic solid is the sum of lattice energy, okay, this will be endothermic, okay, and the total enthalpy of hydration of the ions. So dia kata total enthalpy of hydration of the ions because it is separately, okay, maksudnya this one delta H yang ni and also this delta H, alright, that it will be broken up into aqueous ions, okay, so dia kena tambah sama-sama. Alright, so this is important, you should remember this. This is basically, if you recall, Hess law, okay. So let's look further into the two stages. So basically here we have our ionic solid, okay, this is an endothermic process when you break your bonds between your solid crystal, your ionic solid, okay. This is called lattice energy or delta H lattice, and this will be endothermic. So maksudnya delta H dia adalah positive, okay, sebab dia akan absorb energy to break down the ionic solid into gaseous ions, okay. So these are your gaseous ions. So this is the first step. Delta H lattice, okay, in this form, delta H lattice, it must be positive, okay. If sometimes dia bagi the lattice energy is negative, it is actually lattice formation, okay. Lattice formation maksudnya from your gaseous ions to your ionic solid, alright. But usually in this formula, this one must be positive, okay. Endothermic maksudnya delta H dissociation, okay. Dissociate maksudnya dia dissociate into gaseous ions, alright, daripada your ionic solid. Next stage is the hydration process atau delta H hydration. Kan kita dah ada our gaseous ions, okay. So these gaseous ions will be hydrated with water, maksudnya your water molecules here, okay. Lepas tu dia akan surround your gaseous ions and then it will become aqueous ions, alright. So this process is exothermic, that means it is negative, delta H, okay. So here energy changes during dissolving solid ionic compounds is basically delta H solution lah, okay. This is the definition of delta H solution for you to recall. It is the heat change when 1 mole of solid ionic compound, okay, let's say an ACl solid tadi, dissolves in water to form infinite dilute solution. This will be your aqueous ions. We know that this process is a two-stage process, okay. It does not actually directly form your aqueous ions. Okay, so delta H solution equals to delta H lattice or lattice energy of dissociation, okay, plus delta H hydration. When you already have your gaseous ions, you turn it into aqueous ions. Alright, so this is a visualization of the dissolution process atau delta H solution of your solid NaCl. So right here we have our ionic compound, okay, ionic solid, and here it undergoes delta H lattice, which is endothermic lattice dissociation energy, to form gaseous ions. So from gaseous ions, we want to form our aqueous ions by hydrating our gaseous ions with water. Okay, so this one is exothermic reaction, negative delta H, and finally you will get your aqueous ions. So this one, awak punya ionic solid is already dissolved in water. Okay, so this is basically Hess's law. Okay, so this one is the one-step process equals to lattice energy plus hydration. Okay, this one. Alright, the last exercise for subtopic 2.3. Okay, let's read the question and then we need to identify what delta H that is given. Okay, the lattice energy of NaCl is minus 776 kilojoule per mole. Okay, so this is your delta H lattice energy. Okay, but notice that this is negative. That means that this is actually lattice formation. So you're forming your NaCl solid. Okay, so this is negative, right? So you have to know that it will be forming your NaCl, not dissociating your NaCl. Okay, and the enthalpy change when 1 mole of solid NaCl dissolved in water is plus 4 kilojoule per mole. Okay, so when 1 mole of solid NaCl dissolved in water, is it delta H hydration? Because dia kata dissolve in water? No, okay, it's not, because it says 1 mole of solid NaCl, your ionic solid. So this is actually delta H solution. Okay, kalau hydration tu maksudnya daripada your gaseous ion jadi aqueous ions, but this one is your NaCl solid, your ionic solid. Alright, dissolved in water. So this is delta H solution. If the enthalpy change of hydration of Na plus is minus 390 kilojoule per mole, so this is delta H hydration for Na plus ion. Okay, calculate the enthalpy of hydration of Cl minus. So this is delta H hydration of Cl minus ion in the solution process. Using the energy cycle method. So that means we have to draw our energy cycle diagram. So first things first, you need to write your thermochemical equations. Okay, the first information that we have is delta H lattice of formation, since it is negative. Okay, you are forming your ionic solid from your gaseous ions. Okay, but in our energy cycle method, we will be using the other one, which is plus, which is lattice dissociation. Okay, so that means that it is endothermic reaction where you dissociate your ionic solid into gaseous ions instead. Okay, it is the reverse of this chemical equation. Alright, okay, and then we have our delta H solution, which is from ionic solid to aqueous ions. Okay, and then we have delta H hydration for your ions Na plus and Cl minus. So for Na plus, you are already given. Okay, but this one we want to find. Okay, we want to find this one. So let's start drawing our energy cycle diagram with the ionic solid. Alright, so I want you to draw your energy cycle diagram in this manner, where you have your delta H solution, and then you have your delta H lattice energy, and then you should have your 2 ions, delta H hydration, and another one, delta H hydration. This is the template that will look neat lah. Okay, so let's start with our first equation, delta H solution. So you're going to take this one and then put it here. Okay, so we have NaCl solid, then you get Na plus equals plus Cl minus equals, right? Because solution kan. And then from your ionic solids, lattice dissociation of NaCl, you will get Na plus gaseous and Cl minus gaseous. Okay, so it's that simple. So now you're just going to put in the values. Okay, berapa? Plus 4 kilojoule per mole. Okay, lattice energy of dissociation, which is this one, will be plus 776 kilojoule per mole. Before that, Miss, can I use this one instead of this one? So in this here, I use this one, right? So if you want to use this one, that means your arrow should be from your gaseous ions to your ionic compound. So that means you need to change this arrow towards your ionic compound, and then you also need to change the sign. Okay, so you need to be aware of that. Alright, but in the end your answer will still be the same, but you need to use the clockwise equals to anti-clockwise rule. Okay, next we have delta H hydration. Delta H hydration for sodium ion will be minus 390 kilojoule per mole. For Cl minus, we want to find this, right? Using the rule that I told you just now, clockwise equals to anti-clockwise. What is clockwise? This one is clockwise, and this is anti-clockwise, anti-clockwise, anti-clockwise. So let's put our delta H solution equals to delta H, that is energy of dissociation, plus delta H hydration of Na plus and delta H hydration of Cl minus. Alright, so let's plug in our values. Okay, so to find delta H hydration of Cl minus, we are just going to rearrange. So you will get minus 382 kilojoule per mole. So you will get minus 382 kilojoule per mole for the delta H hydration of Cl minus ions. Okay, so that's easy. Okay, so N of 2.2 and 2.3. So make sure you do your tutorial question and we will discuss it during GM. Okay.